everyone. So this video is mainly about discussing the key steps which one should keep in mind while executing machine learning using Python. And to do this, we will have a close reference to a case study on wine quality prediction, which is a classification problem, and the independent and the predictor variables in this case are all continuous variables. So to begin, first I would like to make you familiar with the data set which has been used. There are two things about this data set which you should be aware of. First is that the independent variables or the predictor variables, which is fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, sulfur dioxide, and the other independent variables, they are all continuous variables. That is, they take decimal values. And the other part of the data set which you should be aware about is the column quality. Here the quality column basically includes quality score, which includes values from 0 to 10, and we have followed a norm that a quality score of 7 and above is to be considered as good quality wine, to be denoted by 1, and a quality score below 7 is to be considered as a bad quality wine, to be denoted by 0. So now we are going to straight away go to the slides, because here our main objective is to discuss about the key steps which one should keep in mind while executing machine learning in Python. So our very first slide is about why this problem, as in why do we execute predictive analytics, or what is the first thing which should come in your mind while executing predictive analysis. So our first point says predictive analytics uses technology to predict the future and influence it. Organizations can use historical data to extrapolate and make predictions about the future and take necessary actions from the business perspective. So a business perspective is very important. In this case, if you consider this wine quality prediction case study, then our business objective here is to arrive at a model such that the significant independent variables / predictor variables, or the ingredients basically, can be summarized, which play a vital role in the formulation of good quality wine. Once you arrive at the significant variables which play a role in the formulation of good quality wine, you can work on those ingredients, and in turn it will add to the revenue generation or profit maximization of the company. So again, if I use a highlighter, you can see that we have to predict whether a bottle of red wine quality is good or not. Although most of us don't really know what makes a good wine, therefore we can apply certain ML algorithm which can help us to understand the factors determining a good quality wine. Here factors mean the independent or the predictor variables which play a significant role in the formulation of good quality wine. So the first thing you should keep in mind while executing any machine learning algorithm is the business objective. Now to our next slide is about the problem statement. Again, officially the problem statement here is to predict quality of red wine. So we are going to build a classification problem, and like I was saying before that we have followed a norm. Again, if I use a highlighter for you, each wine in this data set is given a quality score between 0 to 1. In this project you have to predict the output to a binary output where each wine is either good quality, where the norm has been followed that a score of 7 or higher means good quality, or not, that is bad quality, which is a score of below 7. So the first thing you should keep in mind while executing machine learning is the business objective and any norm which has been followed while to satisfy the predictive objective. Now straight away going to the steps. So first, the main steps which one should keep in mind are the statistically exploring data, data preprocessing, statistical test, data visualization, and perform modeling and predictions. So first I would like to give you a glimpse of the solution of this wine quality prediction problem. People who are familiar to Jupyter Notebook and people who have used Python before would know how this works. So here we have solved the wine quality prediction case study, and as you can see the main steps, just to give you a glimpse, are these. People who are familiar to this will understand. So now I would elaborate each step in detail. So if we are discussing about statistically exploring the data, then you should be looking forward to three things. First thing is checking the dimension of the data. That is the total number of rows and the total number of columns present in your data set. Here, as you can see, the given data set has 1599 rows and 12 columns. Next thing you should know is the column names, which in this case, of course, in the beginning we already saw the independent variables. Our variables here are fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates and alcohol. So if I give you a close glimpse and reference to the solution, then our first step is to explore our data set, that is understand the data set. You see the headings of your variables to know your variables properly, then you see the information about your variables, whether it is a float or whether it's an integer, whether it's an object, categorical variable or any other kind of variable. So here we also have the command of describe, which basically tells you the statistical metrics of your variables, which is the mean, the maximum value, the minimum value, the standard deviation, counts. So if you go to the steps, your first two steps are covered. Now the third step is the data type, which is knowing whether your variable is an integer or a float or an object. Well, if it's a categorical variable, then you might even have to convert the variable into an object. So all variables are integer or float in this data set. Hence, the conversion of variables were not required here. But if you come across a data set which has interpreted variables in the wrong format, then you will have to convert the variable. So statistically exploring a data includes this as the third point, is to check the type of data. Since all variables in this data set are continuous, we don't need any conversion. For example, object. So this covers our first point, which is statistically exploring data. Next is data preprocessing. Under data preprocessing, you should be concerned about 4 points. First is check for duplicate rows in the data. Next is looking for missing values and treating them if required. Third is check outliers and treat them. And fourth is applying feature engineering. So here, if we go by the first point, check for duplicate rows, there are 240 duplicated rows in this data set and we have removed it. Next is looking for missing values and treating them if required. Here we don't have any missing values, but if you come across a data set which has missing values, then you would have to impute the missing values with the appropriate replacement. That is, if it's a continuous variable, then you would replace the missing values with the median value. Sometimes with the mean value, but the median value is preferred because mean is very sensitive to the presence of outliers, but median is not. And if it's a categorical variable, then you will have to impute the missing values with the mode value. Next is check for outliers. In case you have a presence of outliers, you would remove the extreme outliers with the quantile code. So again, to have a close reference and a glimpse of the solution which we have solved, here we have checked for outliers with a box plot, and since here we did not find any such extreme presence of outliers which is mandatory to be removed, we have not removed the outliers, but then this is how it is done. Now the next point. Okay, the last point here is apply feature engineering. Now feature engineering is basically creating another column based on the present columns. Apply feature engineering if required by creating new columns which may help in better understanding of data and predictions. This is usually done when you have to form a separate entire column based on the present columns. Say your clubbing values. Say there are lots of values from 1 to 1000. But you want to club the values from say 1 to 50 is one group, 50 to 100 or 51 to 100 is another group. So when you have the intention of clubbing or grouping values, you consider feature engineering. This is just one example. There are other kinds of feature engineering. It all depends on your purpose. So these are the things which fall under data preprocessing, which is your next step. Now after that are the statistical tests. Since dependent variable is categorical and all other independent variables are continuous, we only need ANOVA here. So ANOVA test is one of the statistical tests which tells you whether the independent or the predictor variables are significant or not. For continuous variable, ANOVA is the statistical test, and for categorical variables, chi-square test is the statistical test. Here we have all continuous variables, so we are only concerned about the ANOVA. So what is ANOVA? ANOVA is analysis of variance. Now analysis of variance, this is basically a hypothesis testing which has a null hypothesis which says that the predictor variables don't have a significant relationship with the target variable, or they are insignificant. That is the null hypothesis. Your alternate hypothesis is that the predictor variables have a significant relationship with the target variable and they are significant. So we would always want the alternative hypothesis to hold. That is why here in our second point we have that the assumption H0, which is basically the null hypothesis, there is no relation between the given variable and the target variable. ANOVA test result, probability of H0 being true when p-value is greater than 0.05. So again in hypothesis testing this norm is followed. If your p-value is less than the level of significance, then your null fails to hold and your alternative hypothesis is valid. And if your p-value is more than the level of significance, then your null is valid and your alternative hypothesis is rejected. So as you can see in our ANOVA, our null hypothesis here is that there is no relationship between the given variable and the target variable. And our alternative hypothesis is that there is a significant relationship between the independent variables and the target variable. So in this case, in this data set, we saw p-value of each variables are less than 0.05. Therefore, every variable is important for making good quality wine. Like I said, if your p-value is less, then your null fails to hold. Here our p-value was less than 0.05, that is, it was less than the level of significance. So our null fails to hold and our alternative hypothesis is valid, which is all the predictor or independent variables in this particular data set have a significant relationship with the target variable. And similarly, if you come across categorical variables, then instead of ANOVA test, you would be using the chi-square test, which again has the same null and the same alternative hypothesis. Now the next thing you should keep in mind, or the next step which you should be interested in, is the data visualization. Under data visualization, there are three kinds of analysis which you could execute. One is univariate analysis, next is bivariate analysis, and the other kind of analysis is multivariate analysis. Now univariate analysis is basically when you are exploring statistically, visually exploring a data individually. Univariate analysis is when I'll show you a glimpse. Say if you consider a histogram and if you are exploring only one variable, say you are exploring residual sugar, this is known as univariate analysis. Here you could understand what is the distribution of values, where is your peak, that is the maximum value, what are your minimum values. So if you want to visually explore or understand the distribution of a variable individually, then you go for univariate analysis. In univariate analysis, the kind of charts which are used are a bar plot, a box plot, and a histogram. Next is a bivariate analysis. A bivariate analysis is when you are trying to visually explore two variables, relationship between two variables. Now that can be your target variable and the independent variable, or it can be between two independent variables. For bivariate analysis, we use density plot or violin plot. So again, if I show you with a close reference with the case study, then here we have a violin plot. Say we are trying to explore the relationship between quality and fixed acidity. Here we have quality in the x-axis and fixed acidity in the y-axis. So this is a violin plot if you're trying to explore the relationship between two variables. Another example is volatile acidity and quality. Next is citric acid and quality. So if you're exploring the relationship between two variables, it's a bivariate analysis, and the last kind of analysis is a multivariate analysis. That is when you're exploring the relationship between more than two variables. Again, if I want to show you a multivariate analysis, then this is an example of multivariate analysis here. As you can see, in one step it explores the relationship between all the variables. This is basically a correlation histogram, is known as a pair plot. Now once you're done with the data visualization part, you come to the modeling part or the prediction part. Here the first step which one should be concerned about is splitting the data into train and test samples, where usually we follow this norm that the train sample is divided as the 70% of the data and the 30% of the data is considered as a test sample. So that is the first step, which is also known as cross validation. Next is apply various possible modeling algorithms to see which model provides you the best accuracy or the best fit of the model, where it can be a logistic regression, decision tree, random forest. Specifically in this case, because it's a classification problem, it's a logistic regression, decision tree and random forest. If you are solving or if you come across a linear regression problem, then your models would be a linear regression model, decision tree and random forest, and other models as XGBoost and other. Whichever model provides you the best accuracy is to be considered as the model of best fit. Now, how to measure the performance of your models? There are certain metrics which tell you how good your models are, and to understand that, what we should be interested in, because this is a classification problem, is the confusion matrix, precision, recall, F1 score and the ROC curve. So if I go in detail, then the first point is about a confusion matrix. So a confusion matrix basically tells you a matrix which gives you the ratio of true positives, true negatives, false positives and false negatives. So what is a true positive? A true positive is the case in which we predicted the quality of wine is good and in actual the quality of wine is good. So a true positive is a case when your model says that the quality of wine is good and in reality the quality of wine is actually good. So that falls under true positive, which is our first cube in the matrix. Next is the true negative. This is the case when we predict, when your model says that the quality of wine is bad and in reality the quality of wine is actually bad. So that is a true prediction of the negative. Next is a false positive, which is when your model says that the quality of wine is bad but in reality the quality of wine is not bad. So that is a false prediction of a positive. Third is a false negative. That is when your model says that the quality of wine is good but in actual the quality of wine is not good. So this is a false prediction of the negative. And if you see this in a form of a matrix, then this is how a confusion matrix looks like. TP stands for true positive, TN stands for true negatives, FP stands for false positives and FN stands for false negatives. Now again, if you want to have a glimpse of these things, then here we have first imported the necessary libraries which are important for the execution of these confusion matrix, accuracy score, splitting of data and regression, which is from sklearn. Now the first thing here is the logistic regression, followed by the other models. Here one of the metrics you could see which would tell you the F1 scores, accuracy, precision, recall, which we will come very shortly. Yeah, so if you want to see a confusion matrix here, then this is one of the examples of a confusion matrix where you can see it's 1 and 0 and 0 and 1. It's in the form of matrix, where again this is true positive followed by false positive, and below we have the false negatives and true negatives. So this is one way of measuring your model performance, that is a confusion matrix. The other metrics are precision and recall. Now precision is the case when you're basically calculating true positives divided by true positives plus false positives. This tells you about the precision of your model, and the recall tells you when you're dividing true positive by true positive plus false negatives, which again in this case, if you see, we have it here. The precision for zero is 91% and for 1 it's 64%, and for recall for 0 it's 97% and for 1 it's 37%. So as it is that this data set is quite imbalanced. Now if you come across an imbalanced data set, then you can use some imbalance treatment. One of the famous method is SMOT. And another metric of measuring your model performance is the F1 score, which is basically the harmonic mean of the precision and recall. The last thing is the ROC curve, which basically plots the true positive rate against the false positive rate. So these are the model performance metrics which tell you about how good your model or how good your fit is. So this is the last point, and thank you. So again, a quick summary of what we have gone through is, when you get a machine learning problem, the first thing you should be concerned about is the business objective and if any norm which is to be followed. Next are the steps, where your first step is statistically exploring the data, under which you should be concerned about first is checking the dimensions of your data, that is the number of rows and number of columns. Your variable names, which is knowing your understanding your variables properly. Third is data type, that is understanding the type of data, whether it's an integer or a float, and if required you have a conversion of variables in the respective data types. Next is data preprocessing, under which you check for duplicated rows. If there are any duplicated rows, then you delete those rows. Next is checking for missing values and imputation of missing values with appropriate statistical metrics. Next is checking for outliers and treating the extreme outliers with a quantile code or feature engineering. After data preprocessing comes the statistical test, which basically tests the significance of your independent predictor variables and their relationship with the target variable. So if you're testing the statistical test for a continuous variable, then you would execute the ANOVA, and if you're checking the significance for a categorical variable, then you would execute chi-square. After you have done the statistical test, you have to be concerned about the data visualization, because it visually tells you the distribution of your data. Now here you can go for univariate analysis, bivariate analysis, or a multivariate analysis, where univariate means exploring or visually exploring one variable. Bivariate analysis means visually exploring the relationship between two variables, and multivariate analysis means when you are exploring the relationship between more than two variables. Now after data visualization is modeling, where first you split the data into train sample and test sample. Next you execute the respective models, which is logistic regression in this case, because this is a classification problem. If you are doing any other kind of problem, then you go for other models or algorithms, and the other decision trees and random forest, and whichever model gives you the best accuracy is to be considered as the best fit. To measure the performance of your model, these are certain metrics, which is a confusion matrix, precision, recall, F1 score, and ROC curve. Because this is a classification problem, and in detail we have already discussed what a confusion matrix means and what is a precision, what is a recall. So Other metrics of measuring the performance of your model is R square and adjusted R square, especially in case of a linear regression. So these are the things which one should keep in mind while executing machine learning using Python. And that's it. Thank you.